Good afternoon, everybody. Thank you for being here to learn about Micronaut. My name is Álvaro Sánchez. Let me introduce myself. I'm coming from Madrid, as you can tell from my perfect British accent. I've been always a Java developer, and I'm working on Oracle Labs, working on the framework, right? Different areas, but essentially build tooling, some modules, etc. I've been working on the framework since the beginning. We started in 2017. I'm going to tell you some insights about that, because originally this was codenamed Particle. So that's how we started, right? And we started with Project Particle, but we soon found that there was like another project using that name, so we had to find like a different name, right? So we ran an internal poll inside the team to find a different name for the framework, and I came with an idea, which is, I think it's magically brilliant, but they didn't like it. I don't know why. So I proposed to name the framework Summer, because we all know that summer is better than it's a joke. It's a joke. No, it's there are good frameworks, Micronaut, Spring, Quarkus, and actually I have only good words about VMware, so we have a really great relationship. So yeah. Slides are available on speaker deck, so if you want to check later. Now, in the meantime, so how many of you have heard about Micronaut before? Raise your hands. How many of you are using it in production? Okay. How many of you are using Spring? You can leave the room. It's over there. No, it's a joke. How many of you are using Quarkus? Okay. Yeah, that's more or less the statistics. So Spring is still #1. But we're catching up. So yeah, let's talk about Micronaut. There's 3 things I would like you to understand from the framework. One is that it's a modern Java framework, and by modern we mean that we started designing it in 2017 and thinking about the type of applications that are created or were created back then, right? So we didn't have to think about how to package an application as an ER file, for example, right? Because we don't do that anymore. Is anybody using ER files here? Or even Word files? You remember that? Now the thing is different, right? So we write microservices, serverless applications, or functions, etc., right? So we had that in mind since the beginning. The second thing is a general purpose application framework, so you can write all application types that you want. Typically, people use it for writing REST endpoints, but you can use it for anything like command line applications, messaging applications, etc. And the third idea is that it's highly optimized. We take performance really seriously. It's one of the key differences with traditional Java frameworks. We use extensively a facility or a feature in Java called Java annotation processors. So at compile time, we do what is called ahead-of-time compilation. If you think about the traditional Java framework, when you use an annotation, like for example Spring's auto-wired, there's many things that will happen at runtime to make that auto-wired annotation to actually work, right? To provide you the dependency that you're requesting. And everything happens at runtime, but at Micronaut it's differently. So we, during build time, during this compiler hook, we essentially react to your annotations and produce the build code necessary to make that work, right? So And that could be dependency injection, that could be AOP proxies, transactional management, whatever. And we do that without reflection, without proxy generation. We don't scan your class path. There's no dynamic classes being loaded, anything. So everything is really fast at runtime, because at runtime, everything is really fast. Another difference or another consequences of this is that the stack traces are like a fraction of those compared to Spring or Jakarta EE, right? So if you compare a stack trace when an exception happens in those frameworks, it's a huge thing. You have many classes that are not related to your code, whereas in Micronaut, they are like really small. Because all the classes that we generate, all the bytecode that we generate, it sits on the same package. So it sits along your code, right? And we generate bytecode for a number of reasons. You can ask me later if you're interested. But essentially, that's what we do. So at compile time, at runtime, we only just execute that code. There's no generation at runtime. It's a general purpose framework, so you can use it with any language, build tool, test framework, reactive library, cloud. There are some images there. So we are currently on version 3, and we're planning version 4 very soon. We're actively working on version 4. So a few things about Micronaut 4. It will bump the minimum version of Java to Java 17. So Micronaut 3 supported from Java 8. So bumping the minimal version will allow us to support many things that happen after Java 8, like virtual threads, with there is like a new HTTP client implementation. And if you're stuck with earlier versions like Java 11 or whatever, you can still use Micronaut 3 that will be supported for years, right? There will be a new version of Micronaut Data, Micronaut Data 4, which will support Hibernate 6. I will talk to you about Micronaut Data later. And basically, everything is smaller, so we've reduced some dependencies. We've made some dependencies optional, so that the runtime is smaller and lighter. So for example, YAML is an optional dependency, so we will default to properties files, which is probably simple enough for many applications. And YAML is a kind of worms in terms of security, CVEs, and everything, so not everybody needs that. But if you still want to use a YAML configuration file, you can. Just that is not by default. And the same happens with Jackson. There is a Micronaut alternative called Micronaut serialization, which is build time again. So that's going to be the default, but if you still want to use Jackson, you can. And there is like a new feature or a new module called Micronaut Control Panel that will make its debut in Micronaut 4, that will essentially display some information about a running application, like, for example, the environment properties that have been resolved. It will display information about the beans that have been created and loaded and discovered. You will be able to work with the management endpoints, like, for example, to change the login information or the login level for packages, etc. So that's a new thing that will debut in Micronaut 4. Some features I will be a bit quick over this because it's like a huge list. But essentially, the features of the framework, the core is like a dependency injection engine. You can use JSR 330 annotations or even Spring ones if you want. In terms of Spring support, we support a lot of Spring annotations, and what we do is at compile time we transform them into Micronaut annotations. So we're able. There is a Micronaut for Spring module that will essentially take a Spring application source code You add the Micronaut runtime dependency, and you are able to run that application as a Micronaut application, but having Spring source code, if it's not too complex, right? There's configuration support for different formats, validation support. There is a Micronaut validation module, which is built-in, is really fast, really small, and is compile time, so it's more performant. But if you need full Beam validation API support, you can use Hibernate validation. There is an AOP module, again, which is reflection-free. This will be a hello world. So Micronaut uses an annotation programming model. So those of you coming from Spring will feel at home with Micronaut. Nothing special here. There's other features like, for example, HTTP client. So if you know what OpenFeign is, you know what OpenFeign is, Spring Cloud OpenFeign. It's a declarative HTTP client. So this is an alternative, but again, the implementation of this interface will be produced at compile time, unlike OpenFeign. In terms of messaging, we support the major technologies. For data access, again, there is a solution called Micronaut Data with two flavors, Micronaut Data JDBC and Micronaut Data JPA. We support for the major technologies again. It uses the repository pattern, so this is familiar to you as well, probably. Again, the difference is that everything is generated at compile time, even the queries, etc. Regarding security, again, there are annotations to define security rules, or it could be configuration-based. There's full auth2 support, OpenID Connect, etc. So essentially, we've got you covered regarding security. And then there are more things, distributed tracing, service discovery, distributed configuration, monitoring, etc. Cache, email, blah, blah, blah. Many things. How do you get started? So there is a website called Micronaut Launch, where you can select the features that you want, the application type, and we will generate the application for you. Or you can, from there, push it to GitHub directly. You can use a command line if you prefer that, but it's essentially the same. It's the same backend for a different front end or way of using it. There is an IntelliJ IDEA wizard in IntelliJ IDEA Ultimate Edition, and Visual Studio Code extension to create an application. So, like I said, they're all the same, the same backend behind. Now, some notes about GraalVM. Who heard about GraalVM here? That's good. Who's using GraalVM to deploy? Fair enough. Where's GraalVM? GraalVM is an OpenJDK distribution. It's like any other OpenJDK distributions that you may find out there. The difference is that this one has an additional, well, there are more differences, right? But the one that made it famous is that it has an additional component called Native Image. I will get there later. But essentially, you can have like two routes from your application. You can use your application in JIT mode, like any other OpenJDK distribution. Right, so I personally, for example, use GraalVM as my local JDK for everything. So nothing changes. That's what you're already used to. Or you can use the native image component to produce a binary of your application. Right, that's the AOT variant. And also the Micronaut and GraalVM combination is especially great. So this native image binary of your application will start dramatically fast. So Think about a Micronaut Hello World will take on JIT, on modern hardware, will take around, I don't know, 250 milliseconds, something like that. When compiling to a native image, it can take as low as 6 milliseconds, right? So that's insane. More complex applications may take, I don't know, 50 milliseconds. So we'll see later in the demo an application using flyway migrations and schema generation, SQL inserts, and blah, blah, blah. It takes like 35 milliseconds to start. And also the memory consumption is much lower as well, which is great. Again, Micronaut and GraalVM, because you can find GraalVM support in all the major Java frameworks, that's true. But the combination of Micronaut and GraalVM is unique. Why? Because first of all, they are both developed on the same organization inside Oracle Labs. So we're working together, right? And there's even for the enterprise version of GraalVM, there's some licensing benefits when using Micronaut, even in Oracle Cloud. The other reason is that Micronaut is ready for GraalVM since day one, unlike other alternatives, right? So because we never use reflection or anti-proxies. It's not that you can't use reflection with GraalVM, you can, but normally, well, even with recent versions, it will detect them automatically. But there are some corner cases where you have to essentially provide a GraalVM some configuration metadata. Regarding the GraalVM support for third-party libraries, there is an initiative between Oracle, VMware, and Red Hat called a GraalVM metadata repository. So, the major Java frameworks are collaborating together to produce a single repository of metadata for libraries like, for example, Netty, right? So initially, we had our Netty configuration metadata support for GraalVM, and the others has like a different approach. So we're consolidating them into a single place. I think that's already happening with Spring Boot 3. It will happen with Micronaut 4 as well. You will use the same configuration metadata repository. So I really appreciate the willingness of VMware and Red Hat to collaborate on this. And the other reason is that there is tooling support written by Oracle Labs. One is the native build tools. Native build tools are build plugins for Maven and Gradle to produce a native image. Those are being used officially by Spring and Micronaut. And the other tooling is the extension pack for Visual Studio Code that allows you not only to use GraalVM, but also Micronaut. There is a use case published by AWS that shows Disney Plus using Micronaut and GraalVM for one of their systems. I recommend you reading it because it's really interesting. It shows one of the use cases of GraalVM, which is serverless computing, serverless deployments. So with serverless, the issue normally is called startups, right? So normally in Lambda, when the first request to a Lambda will pay the price of a cold startup, and then the Lambda will be kept warm for a while. So subsequent invocations will be much faster, but the first one will be a bit slower. So they realized that giving more memory to the Lambda would reduce the startup time. So it's about to make the numbers. So maybe it's worth to have a more expensive Lambda that takes less to execute than the other way around. And then the comparison with JIT Java versus GraalVM Java is incredible, right? Not only on the startup time, but also on the memory consumption. If you want to learn more about GraalVM, there is a talk at 4:20 from Alina. I don't know if she's here. She's not, okay. Alina, a developer advocate for GraalVM, will tell you more details about GraalVM. And now we have a demo. Questions? Well, we can leave the questions for later. Okay. I don't know if you're seeing. Yes, okay. We're done. So we have a skeleton of an application, of a Micronaut application, which is empty. So the only thing what I did is, well, I generated an application from Micronaut Launch using specifying the features. So I wanted GraalVM, I wanted Micronaut Data JDBC, H2, the database for testing, and Flyway. So that gave me all the dependencies in the POM, right? So that hasn't changed. And the only thing that I did is to create the migrations to create the schema. Let me make this bigger. Yes, that makes sense as well, yeah. This is... Any better? Yeah. So yeah, so that's the schema and some data. So this is like a dummy football team management application with a couple of teams. Who likes football here? Yeah. If you're supporting Liverpool, I'm really sorry for you. So let's create something. So I'm going to create like the entity class. This is going to be a record. So this is a entity. And then this is ID, generated value, long ID, string name. Steady. Now I'm gonna create a repository, and this is going to be team repository, an interface. So this is a JDBC repository in the dialect. It's going to be S2. We have to specify the dialect here in the annotation because this is not going to be processed at runtime, but at compile time, right? So ahead of time, we need to tell which is the dialect. So if you wanted to have different dialects being supported, so it's a matter of having like a parent interface with the methods, and then the child interfaces with the annotation and the dialect. And using Micronaut conditional beans features, you can choose which one you want for a particular environment. So this one extends from Graph repository, which is an existing application, an existing interface that will give us the typical methods like find all, find one, etc. And we have to specify the entity class and the primary key class. What else? Let's create something called Team API. You will see later why I'm doing this. So this is going to be an interface. I'm going to create a constant here called path equals /teams. And then a couple of methods. One is iterable of team find all. or list. And the other one is HTTP response of a team get, and when we post the ID of the team. And we annotate this with @get. And this is @get, and we specify a path, which is ID. I'm going to cheat for a moment. Yes, with a slash. So far, so good? Yes? Now let's create the controller. This is going to be a class that implements the interface. So I'm going to implement the methods. And then this is a controller, which listens on the path variable, this guy here. And we're going to be declaring dependency on the repository. So private final team repository. Right. A constructor injection by default. No need to add any annotation. So Micronaut will figure out that it needs to find a team repository instance on the application context and will give me the result. So the list operation is simply returning repository final, find all. And there's several things you can return from a controller. You can return entities or collections of entities, and Micronaut will serialize that to JSON, like you would expect. Or you can wrap them in an HTTP response object in case you want to, I don't know, to change anything about the response, like headers or whatever, right? So what we're gonna do here is repository find by ID, and then we transform this to what? HTTP response OK, or else this HTTP response not found. So far, so good? Yep. Let's run this. Oh, what's going on here? I'll do a clean because I think I was playing with this before, just in case. I don't trust myself. And then there is a Micronaut build plugin for Maven and for Gradle that will essentially run the application. Well, it will compile the application and run it on development mode with hot reloading. And of course, it's not working. I think the demo gods are not with me today. But don't worry, because I have a plan B, which is to use the solution. It's probably network or anything. The network isn't great. Yeah, something was wrong. So let's try again this guy here. There we go. So now we can run, actually I will use this terminal. So we can say curl 08080/teams pipe JQ. And there we go, right? It works. So far so good. I can get team number 1. This is by ID. And if I get a non-existing ID, I should get yes, 404. Yes, so it works. It was really easy, really fun. The other thing I want to show you is how to write a test for this, because testing with the terminal is great, but I prefer to use to write a test. So I have an empty test class here. I'm going to use unit 5. And the first thing I'm going to do, because I want to test, I want to write a functional test or an integration test, depending on how you call this. But essentially, I want to spin up an instance of my application on a random port, and I want an HTTP client connected to this random port, and I want to send HTTP request to this endpoint and then make assertions on the response. So how do we get a client? You would say, so this is really easy. So I will create a class, or actually interface here, static interface team client, extends team API, right? This is the reason why I created a team API interface, so that both the server and the client can use it as a contract. One has add controller, and the other one has add client. It's that simple. And then I want to inject this controller in my test class, because this test class has microtest annotation and essentially becomes Vim as well. So I can inject a team client here, and then write the tests. So we can test list, and then this is a test. Unit Jupyter, yes. So I can say client. As you can see, we have the methods. So we can say that assert equals, and then we're going to be casting this to a collection. Collection of team to call the size methods. Size. Right, let's run this. It's passing, but now you may say, you're cheating, so how could this be that fast? So are you telling me that this is running an instance of the application and actually sending an HTTP request, receiving the response, doing the marshalling and unmarshalling of the JSON? Because I knew you wouldn't trust me. Ahead of time, I made a change on logback configuration to have the HTTP client log level to trace. So if we see this, we can see it's actually sending an HTTP request to the server and getting an HTTP response. You like it? Yeah, it's great. So testing experience is absolutely amazing, as you can tell. 437 milliseconds to run a functional test, right? This is For me personally, this is one of the key differences between Micronaut and other frameworks, right? And it's because how the framework is designed, right? So the other thing I want to show you is the native image. So let's create one. So we only run Maven package and specify a property of type native image. The Micronaut Maven plugin supports different packaging types. So when you do Maven package by default with no other options, you get a jar file, but you can produce a native image, you can produce a Docker image, and you can produce a Docker image with a native image inside. Yes, I've been demoing this like for several years. In the first editions of GraalVM, I didn't have time to run the actual native image compilation live, but now GraalVM is much better. I've got like an M1 laptop, which is great as well, so it should work. It's about a minute to finish. I have an image prepared in case it failed or in case you wouldn't trust me. So this is took 1 minute, literally 1 minute, and it's on the target directory, so we can run it. Let me repeat it again, because if you link it, you miss it. 31 milliseconds. This is awesome. And it's doing the flywheel migrations, by the way. So it's a couple of one table, right? Not rocket science. But it's, I think it's really, really great, isn't it? I need to exit this. So that's essentially all I have for you. So we have some time for questions. There is a question over there. Repeat again, I couldn't hear. Test containers. So the question is test container supported? The answer is yes. We have a module called Micronaut Test Resources. So you can use test containers as you would use like directly from the website. You add the dependency, you start the containers as you would in your test. That's like the manual way. Or you can use Micronaut Test Resources. With Micronaut Test Resources, we essentially we detect that you have configuration and you have dependencies for, I don't know, a database container or message system container, right? We detect that based on your configuration and your build. And based on that, we will transparently start the required containers before the build. So you will get test containers for both tests and local development, which is great. And you don't have to worry about like setting up. So you won't change your test at all, right? Because it's part of a module that kicks as part of the build plugins, right? Micronaut test resources will actually execute before and will decide. There is like a separate component that will, because there can be multiple scenarios. Like for instance, I want to run in development mode, but I don't want my test container to be destroyed between executions, right? So you can do that. You can have two applications, a message consumer and a message producer, and you want to share the same Kafka instance, for example, so that you can do that. There are multiple scenarios, so it's really great. I totally recommend it. Is there any other question? There is a question over there at the bottom. Right. The question is the $1 million question. So differences between Quarkus and Micronaut. I think both of them are similar in a way that they're trying to solve a problem that was basically not answered before, right? And the problem was that we're no longer creating Word files, or we're no longer creating. So it's really difficult to have a framework that was designed 20 years ago, or 21, I can't remember, and then change it over and over and over and say that is the way you should be writing applications today, right? And then you have startup times that are 10 times than they should be, etc. So both Micronaut and Quarkus try to solve that problem. The way they do that is differently, so they don't use annotation processors. And I think other than that, they are similar in a way that they are general purpose application frameworks. You may find, for example, better GraalVM support with Micronaut. You may find better OpenShift support in Quarkus, or better Hibernate support in Quarkus, possibly because it's driven by Red Hat. But I think it's subtle differences. I personally, for example, prefer the testing experience of Micronaut. You saw it. I think it's great. It's really worth it. And yeah, I think as well that the reading annotations via annotation processors is the way that it should be. The Java annotation processing API has been like forever in Java, but nobody used it, basically. There's like other alternatives like Google Dagger, which was a dependency injection for Android. You could use, there's people using Micronaut in Android applications, for example. So using Micronaut and GraalVM, or simply Micronaut, right, enables you to introduce Java or this framework in places where you wouldn't be able before. Is there any other question? There is one over there.
The GraalVM Enterprise Edition. So that's the performance impact you said. How much is that?
The Enterprise Edition.
Yeah.
So the question is, in GraalVM Enterprise Edition, what is the performance difference? As far as I can tell, GraalVM Enterprise Edition has, I think Alina should be able to explain this better than me. GraalVM Enterprise Edition has something called profile-guided optimizations that will make Java code even faster than their like native counterpart. So they're doing like amazing improvements in how to produce this native binary, and those special optimizations are only available in the Enterprise Edition. Another thing that I should mention is that native image, the native image component has been donated by Oracle to the OpenJDK project. So in the future, starting with Java 20 or 21, I think it's 20, all OpenJDK distributions will come with native image, which is great. I think this is a great contribution, and it's a great way to move Java forward for everyone, not only for Oracle customers. So you have like the community edition of GraalVM for free today with GraalVM JDK, and in the future with any. So how many of you will start using Micronaut after this presentation? Don't be shy, raise your hands. All righty. Thank you very much. You've been a fantastic audience. I hope you learned something new and enjoy the conference.